Okay, in this video we are doing Calc AB Problem Set 58 problems playlist in the description. Let's answer some questions. Number one, use the limit definition of the derivative. Oh, we're going way back. To find f prime for f of x equals square root of 3x plus 1. I think it's a really good idea to think about the limit definition like once a week because you're gonna see it. A lot of the way you mostly see it on the AP exam is you have a limit and then the question is like evaluate the limit, and you look at the limit and you're like, oh my god, how would I do this limit? But then you realize it's actually a derivative and you just take the derivative. But the more you think about the definition of the derivative, the easier it is to recognize that. So the definition of the derivative is f prime of x is the limit as h approaches 0, f of x plus h minus f of x, all divided by h. So that's what I'm going to do to begin with. So it's limit as h approaches 0. We're going to have f of x plus h. So every x that I see becomes an x plus h in parentheses, so that we're very careful to distribute correctly, minus f of x, which is the original function, and then all divided by h. So in this particular case, I mean, like at this point in your life, you would not use the limit definition on this, but it's good to remember, like there's a weird radical thing. I don't know what to do with it, so I'm just going to rationalize the numerator, which means multiply the top and the bottom by the conjugate of the numerator. So that changes the sign in the middle from a minus to a plus. So we have this. Then the whole point of doing this is that the numerator, it's kind of like you have a minus b times a plus b. It's not kind of like that. You have that. A minus b times a plus b, which is just a squared minus b squared. So I'm going to do that. So here goes. The limit is h approaches 0. First, I'm going to get 3x plus 3h plus 1. So that's like a squared minus the quantity 3x plus 1. So do you take that second part after the minus sign, always put it in parentheses. You'll make mistakes sometimes if you don't do that. If you do it, you'll make a silly mistake now and then, but like not anywhere near the frequency. Now in the denominator, there are two important things to remember, and those are the two things that should be in the denominator, right? There should be an h, and there should be that the h is the original, but there should still be a radical blah plus radical blah, like the conjugate, should still be there. I see a lot of people forget that. And then it's like you get the answer and the answer looks really weird and people are just like, yeah, okay. You know the answer to this problem. So like screwing it up along the way, you would at least know that something has gone wrong. Anyway, at this point, I'm going to cancel everything in the numerator that doesn't have an h. So that's going to be the 3x and that minus 3x, the 1 and the minus 1. And then there's a 3h over h, which leaves us with just 3 over that stuff. And now if h is equal to 0, we have 3 over 2 root 3x plus 1, which we know is the derivative of that function. So good deal. Even now, it takes a while to go through a derivative. I mean, it's like they're not super hard, but you have to do a lot of algebra. Next problem. Whoa. Find a, b, c, and d so that y equals ax cubed plus bx squared plus cx plus d has a relative extremum, either a max or a min, we don't know. It doesn't really matter, it just has one, at negative 2, 4, and a point of inflection at the origin. So there's a lot of information here that you may not realize is necessarily there. So the first thing is the point negative 2, 4. So like, sure, there's a relative extrema there, but first off, the point negative 2, 4 has to be on this function. So we can take negative 2, plug it in, and then set that equal to 4, and that'll give us our first equation. So our first equation is 4 equals negative 8a plus 4b minus 2c plus d. It's our first equation. Okay, so then we also know there's a relative extrema there, either a max or a min. So what I'm going to do is I'm going to find y prime, which is just power rule. And then after I find y prime, I know that if I plug negative 2 into y prime, I should get 0 because there's a relative extrema there, right? And so that means there's a critical point, and critical point, either the derivative is 0 or undefined. This derivative is never undefined, so it must be 0. So I've plugged in negative 2 for x into y prime, which gives me 12a minus 4b plus c, and I know that that equals 0. So I have a couple of equations going now, like 2. Okay, so the other thing, or the next thing that we know, I guess, is that there's a point of inflection at the origin. And at the origin means that if I plug 0 into the function, I need to get 0 back because the point 0, 0 is on the function. So that means that d is 0, right? Look at that function, y equals ax cubed plus bx squared plus cx plus d. Plug in 0 for every x, you're just left with d. We know that when you plug in 0, you have to get 0. We actually know that d is equal to 0 at this point. That's good because we're like 1/4 of the way there. We like already solved that. This is talking about a point of inflection. That involves the second derivative, so let's find the second derivative. Y double prime is 6ax plus 2b. We know when we plug 0 into the second derivative, we have to get 0. And if you look at that, that means that b must be equal to 0, right? Because the 6ax goes away. When we plug in 0, we get 2b equals 0. So b is 0. So we already know two of the values. We know b and d. As a consequence, if we go up to that first function, b is equal to 0, d is equal to 0. The only thing we have left is negative 8a minus 2c equals 4. We know that b and d are equal to 0. In particular, that means from our second equation that we found, since b is 0, we know 12a plus c is equal to 0. And now we're like basically done. I don't know. I need to solve this system. So I'm going to multiply the bottom by 2 and then add down, which will give me 16a. The c's should cancel. That's the whole point. Equals 4. So a is going to be 1/4. And then we also know that, what do we know? We know a is 1/4 and, I don't know. The next thing I wrote was negative. Where did I get this from? Oh, okay. Negative 8a. I couldn't figure out where it was coming from. So I looked at negative 8a minus 2c equals 4. I plugged in 1/4 for a. That gives me negative 2 minus 2c equals 4. This is a really good example of where, like, sometimes your work is not good enough. Like, I've gotten the correct values of a, b, c, and d, but if I was grading this, I personally am confused by my own work. As you heard, I was like, where did I get this value? So maybe you want to do a better job than I have done there. Always a good idea to do a better job than I've done. All right, let's look at the next and final problem here. Evaluate the derivative of arctan. Always good to take a derivative of arctan of 5x. All right, so the derivative of arctan is 1 over 1 plus u squared times the derivative of u. So the derivative of 5x is going to be 5 to the x, natural log of 5. And then it's all going to be over 1 plus u squared, so 1 plus the quantity 5x squared, which I think you could probably leave depending on like what world you're doing this problem in. Another option is 5x squared is like power to a power, multiply the power, so 5 to the 2x. I don't know. I think I would probably write that and leave it that way. I think you might see 1 plus 25 to the x, which is just kind of confusing in my personal opinion, but like whatever. Also, if you do this on a calculator that is like a CAS calculator, you might see like a cosh involved in the answer. We don't need to worry about that. When that happens, you know, either you can type in your answer equals that answer and see if the calculator says true, or you can just find another source or just, you know, do the problem again and check your work. Cosh in hyperbolic cosine, hyperbolic sine will show up occasionally when there's like exponential things, and there's really nothing you can do on a calculator to make it not happen. So you just kind of have to accept that as a fact of life. Anyway, we are done with this problem. We're done with this problem set. I hope this was helpful, and good luck.